stable, fault tolerant, NoSQL database which supports replication across multiple, provide low latency for users. So here I emphasized three things. Scalable, that's an important part. Once your data is growing, it is scalable. Highly available, like whenever you need it is, you can get the data from your cluster. And if something fails, it is fault tolerant. And there's the two other thing is also important, supports replication. So that replication is one of the dealing with the big data. And I will talk about a few replication methodologies which has been used to in NoSQL databases. And low latency, whenever you wanted to read the data and you should be able to get it fast, that is low latency. So what this Cassandra database is suitable for large volume of mission critical data. It is Amazon's Dynamo and Google's Bigtable. And as you may already know, like the Google's Bigtable was one of the paper presented by Google, and most of the implementation happened based on that Google's Bigtable presentation or the white paper which came out. This Cassandra database was primarily developed at Facebook, and in 2008 donated to the Apache Foundation. And since then it is becoming and contributed by open source community. What are the common use cases of Cassandra? So let's discuss where it is more useful, and with that I will also discuss where it is not at all useful. So the one of the case is the big data, definitely, because it is distributed database. It can maintain a history of talking about a application which is in shopping. Then it can maintain the impressions, prices, product, locations, scans, and as you know, like if you are dealing with millions of items, and the data can grow significantly every day. So it can deal with that kind of a data, which is provide a lot of logical analysis. Time series data, and it's like time series data means like your stock prices, which is changing every moment over a time. And your processing data, so we are monitoring your processes. That is time series data, and that is very well handled by this Cassandra. So there are the two examples, and that is I think I took it from Cassandra Planet. These are Cloud Click. This is the application monitoring data of different matrices checked by the Rackspace system and rolling them in a time scales. So that is a very large amount of data. It is generated about different systems, and it is used for monitoring. There are also another marked up application to analyze the desktop application performance and application data. This is also bought by Microsoft later. The third use case is the logging data. The logging data is one of the area like where you have logging. You're working on an activity, and one of the big example is Modal. This system record user activity logs and topics for question and answer. So like he churns the logs and then identify that what topic can be identified from that log, and generate the question answers. Now I will move to the when not to use Cassandra. First, lack of asset transaction support, and you know that like asset transaction is the core of relational database, and it does not support asset transactions. Another relational database is very well known for joins, and Cassandra definitely lacks the join support. It can be achieved, but it is very limited. Third thing is the security. Relational database has a role-based security, column-based security, and various kind of security. But in Cassandra, it's at a very granular level. Fourth thing is the application handling business critical data. So because I will just talk in a later slides, uh, Cassandra provides the eventual consistency. So it is not suited for banking and insurance applications. Another thing is where application requiring a long transactions, like where there is a commit and rollback, multiple commits and rollback. It is not a good use case for Cassandra. So I just wanted to quickly check if like a speed is okay, or I'm too fast or too slow. Now, with this, one of the important thing is when we are talking about NoSQL database, this is a completely a different methodologies compared to the relational database. And here it is always what's the difference. And I have created this table, collected a lot of attributes from different places and to analyze it. So first thing is the data modeling. And in relational database, it is perceptive. Means you have to upfront design your schemas. You have to fine tune them. You have to normalize. And in NoSQL database, it's a very flexible structure. You can you can decide when you get the data, and based on that data structure. So it's descriptive. Asset transactions, relational database provides full support, while NoSQL database not always provide the asset transactions. ETL, extract, transform, and load, is like one of the core to analyze used for analytics in relational database. So the data from multiple applications come to a common data warehouse system, and from there it is used for different dimensions and created to just analyze and create the report by the business user. In NoSQL database, it is not required. So it is like the data is created in terms of where it can be read. It is more designed the way like how your data will be read, not the way how you will write the data. So requirement of ETL systems when we are using NoSQL database. Scalability, that is again it is works relational database works on a high performance machines, which is commonly located at one or two places. On the other hand, NoSQL database is distributed by design. So they work in a distributed environment. The index, again, there's a very strong point of relational database, and NoSQL database only provide the partial support for that. Security, we already discussed about high security, and it's at a not at a granular level. SQL support, again, like when we talk about relational database, we think like that SQL is the one of the core, which is since like it's a very beginning. In the relational databases, we are not always get this SQL kind of support. Though Cassandra is a very good suited, and it works similar, has its own SQL language. I will just discuss and show the examples while in demo. Sharding is the this is the methodology where you partition horizontal partitioning of databases. In this sharding puts different shard on different servers. Each of these servers can have their own IOs. So means like you have to increase the efficiency and partitioning the data so that your data can be read fast. Multiple data center replication. So that is where you have a different regions where your data, you are replicating the support. NoSQL database provide a they are designed to provide that kind of a support. And the last one is the asynchronous query, and relational database provide a very limited support where they are supported in NoSQL databases. So as we are null and NoSQL database, so here I wanted to what differentiate NoSQL database. What are the factors and how it improves? Well, like one NoSQL database to another NoSQL database. What is the design methodologies has been used? So there are the primarily three factors. First one is the data model. What kind of data model has been used? So we will go in these data model one by one in details. So let me read these are the four categories. One is the key value store. Second is the column family. Third is the document oriented, and fourth is the graph based. Now key value store, if you can think of, it is similar to Windows registry where you define the registry key, and in the C and Java also you can have a hash map. The second thing is the column family is multi-dimensional map. Basic unit is column, and that is columns are arranged in a column family and then rows are generated. And Cassandra is one of this kind of database. Document-oriented database, it is designed for document or semi-structured database, semi-structured data. So the basic unit in the document-oriented database is the document. And the fourth is the another kind of a database. It composed of node and relationship with highly connected network. And these node and relationships can have individual properties. So like when you see the graph database, those are mostly how the people are connected, how they are related, and where the graph-based database are used. Second thing is the second factor is the distribution model. So when we are defining the NoSQL database, which NoSQL database and what methodology has been used. So in the distribution model, we have two things: sharding and replication. Again, consists of two things: master slave and peer-to-peer. So again, second differentiating factor is this distribution model. If we talk about sharding, I explained it's a horizontal partitioning of the database. So you put different shards on different server, and every server has its own IO, 1 gigabit or what kind of, so that it will provide a read efficiency. Second thing is what we discuss is the replication, how data is replicated. First is the master slave. Master slave replication synchronizes the data on the multiple server when one server is designated as master or primary and other server becomes secondary. For incentive operations, and the thing is the resiliency is on the slave, not on the master. Second, the last one is the peer-to-peer. In peer-to-peer application, what we have a different server. They have the equal weightage. There's no master and slave, so they are equally weighted, and they are making a kind of a ring architecture. And Cassandra is one of this kind of peer-to-peer architecture. It is important to discuss about the protocols, like when you have a database, how they interact with the applications, how they interact with other systems, and that is comes under protocol. And so there are primarily some of the NoSQL database has their custom protocols. Some use very standard HTTP and representative state transfer, which is called REST. And these they use the open for standard communication because these are the standards. And some uses the thrift protocols to have a communication around the applications and intercommunication. I think I will this slide quickly.
Yeah.
So when we think in terms of like we discuss in terms of relational and NoSQL database, and now we are one Cassandra and in a big data perspective. So before I move to big data, I just wanted to what so in terms which have 3 V's, and these 3 V's is the volume. So volume means like we have easily have a gigabyte of data, then which is growing further, which is getting into the terabytes, petabytes. So that is really velocity is like the
all the money I spent, all the time I spent on the phone with these people.
The pace which data is coming to your organization. So it comes real time by different, if you are by different user groups. It can come hourly or daily, like your conversion file or like a currency conversion file which comes daily, or that comes like some files, payment gateway files, or those kind of files come weekly. So there is a lot of velocity, and it is again we are talking about some unstructured data like Twitter and some of the survey data which is coming at a, so what pace your data is coming, so that defines the velocity. Variety, again, data can be in any format, CSV, SQL, JSON, whatever it is, and PDF, Word, or plain text file. So that's define the variety. So volume, velocity, and variety. These are the 3 things which determines and important for the big data. What is required in big data? Once we have big data, I will show you why we go into the distribution model when we have a big data. First, it requires the multi-region availability. So like you are in a US region, somebody is in Europe region, then everyone need to have the access to data, no matter if you have like a 20 servers in US and 30 servers in Europe. So multi-region availability is the one of the important thing. And it's a response, again, the fast and reliable response is required. And if something fails in between, it should not bring the whole system down. It should, there should not be no single point of failure. So I will wanted to just tell about what is the advantage, and I think from the presentation which we had on big data. So one thing is like you can understand 1 terabyte is a simple unit, and now if we think of a network speed of 100 Mbps, to extract that data from 1 terabyte of data from that disk, it's a simple calculation, 1 terabyte by 100 Mbps. So that comes to around 10,000 seconds, and which is equivalent to 133 minutes, equivalent to 2.8 hours. So 100 Mbps is a pretty good speed. And if we think to extract 1 terabytes of data, what will happen if the data is the hundreds of terabytes, or if it is growing further? So what in the distributed model happens is you divide this data into the different nodes. So if you divide this data in a 50 nodes, and if we do the calculation, the seek times comes to 2 to 3 minutes. So that's the advantage of having a distribution model. So here is I put a representation. Then if it is growing, we cannot increase. If you will see that the server, we cannot increase the size of the server, because it becomes costly when you enhance the performance and enhance the resources. So if the data is growing quickly day by day, what you have to do, you have to distribute it among the various systems, and that is all the distributed architecture are based. Now I will go back theorem, and this CAP theorem is closely related to the NoSQL databases. CAP is acronym for three characteristics of a distributed system. First is consistency, availability, and partition tolerance. Consistency means all nodes in a cluster see exactly the same data at any point in time. Availability means every request received by a non-failing node in a cluster must result in a response. Partition tolerance means that a node can still function when communication with other group of nodes is lost.
You can change it.
I just sit here and watch.
So in a distributed system, out of these three characteristics, at most only two characteristics can be obtained. And relational, so if we see that, like, it is so let me just get a little bit of emphasis on this consistency and availability. So we have these three characteristics, and if we see these three characteristics, most we can achieve two at a time. And I will show you into the next slide. I have a next slide for that. So I will show all the databases, how they are related with these CAP theorem. Okay, consistency. We discussed here in the previous slide about the consistency. Means all nodes in a cluster see exactly the same data at any point of time. But have you understand the problem when you have 100 of nodes, and if you're writing at one node, it might take a time. So I have tried to represent this with this graphical diagram. We have a trade-off between weak and strong consistency. We can tune the distributed environment for that, the Cassandra environment. So in the example, I tried to show DB may not be consistent at point initially be consistent. So in the example, what we are showing here is we are showing the 5 nodes, which is node A to E, and packet received by node A and E. So now we have these 3 other nodes. So there is it might not happen. These other 3 nodes will get the packet immediately. So given a sufficient period of time, all the nodes will be eventually be consistent. So that is what I'm trying to display, that like what consistency means. Like you are looking for a data, it might not be there on a certain node, but it will be eventually. And another thing is like updates are fast and takes fraction of second in distributed database. And and with the Cassandra, one of the advantages is it can be tuned. It can be tuned for consistency. So like if higher the consistency, uh, uh, then your latency will affect. So when we say that like now we will just talk about this design trade-off and the cap theorem and eventual consistency. I have this design trade-off. We have discussed about this availability, partition tolerance, and consistency, and we said like all three is not possible because uh, there are the design methodologies. So two can be addressed by these SQL or NoSQL databases. And partition tolerance is the common characteristics that partition tolerance is the common characteristics that all exhibit for scaling. So this is only where the distributed database comes into the picture, or NoSQL databases comes into the picture. So there are in the NoSQL database, if you will see, there are the two methodologies. One is availability and partition tolerance. If you go into the first top edge of the triangle, availability in the left and partition tolerance. Availability and partition tolerance is provided by the system by three databases: Cassandra, Apache project, and this is Amazon Dynamo.
Did you pay for it?
If we think about the partition tolerance and consistency, that is more good for a read-oriented operations, like where we dump a lot of data, and this is like Google's big table, HBase, MongoDB, and Redis. To the partition tolerance and consistency. So data is consistent. It means like you will get the exactly what is written, and if any partition tolerance means any failure of node will not affect your so you will get a good picture. Your availability might not be affected, maybe affected. It doesn't taken care. On the other side of this theorem is availability and consistency that you have been seeing from many years. They are consistent throughout, consistent, and they are available. That is Oracle, all the relational MySQL or SQL Server, uh, SQL database, they are all available and consistency. So this is cap theorem, and in terms of eventual consistency, where they lead. So it now you know like what is the design. Then why we are discussing these, like when you're picking in an application, which you can decide what are you looking from that application, which NoSQL database you have to pick based on these characteristics. Now I will go a little bit into data model. I have just picked like very simple 4 things. I don't want to just get into more details. So in the Cassandra model, I just tried to do a apple to apple comparison, but it is not always the same because they have a different methodologies and different way of representing data. So in Cassandra, and in relational model, we have a database. In Cassandra model, we have a column family. We say it a table. I will just explain in next slide about column families and keys and column. In Cassandra, we have a key, and similar to relational model, we have a primary key. And the single most unit in Cassandra is the column, and in the relational model, it's a column also. we also have a one thing is called column value. So it's a very straightforward to just make a familiarity with the Cassandra model. So key space, column family, key, and column. So now I have just tried to see what Cassandra column look like. And the Cassandra column look like it consists of a name, it consists of a value, it consists of a timestamps, and this another thing is this is a columnar database. So it is not like if even then you see the familiar name, but the way it is represented is different. There is another column called time to live. That is the optional expiration date to mark the column deleted after expiration and physically removed during compaction. So what will happen, you have some data which you define time to live, and it will automatically delete it, that column, uh, and then it will be physically removed when the compaction algorithm will run. Now I will go little bit, I think this will explain little better a data model, this slide. If you will think in terms of this Cassandra row, so there is a row key, and row has a column, another column, and column. So Cassandra row has set of columns uniquely identified by the row keys, column stored in a sorted orders. It is both column oriented and row oriented. We don't have a timestamp for row, and number of columns and names can differ. So like, I think not to give a different, the upper slide has a little bit, I just try to bifurcate. For example, if we have some user database, here we will do the same example. We'll have a name of a person. So it has only two columns, and this first row, we have a row key, we have a name and age. Second also row, we have a name. For example, if we don't have a age here, then we see that how every row has a different data in every row. So it depends, like when we store together name and value, name and value. It's because it's a key value pair database, so that every row will record the data the way it is represented. So in the fourth example, we have a name and a sex, but no age column. So that is the way the data is presented in columnar database in Cassandra. We will see when we will just inserting the data and creating this table while we are running the Cassandra. Now, another important thing which you should understand about the Cassandra language is it has a Cassandra query language that is called CQL. The most advantageous feature is it is similar to SQL, so you need not to learn any new skill. You can create in objects in DDL. It again has a DML component, insert, update, delete, and today we are going to show that also. You can query data will select. So like this is a user and this is in a node of Cassandra cluster, and they can just write the query select a star from users where user key is CK21 and can access the data. So this is where the Cassandra database provides the SQL-like query language. As we discussed so many things, I'm just going through some of the advantages we have in Cassandra. So first thing is the flexible schema. You see, like you need not to worry about defining upfront the schema. You can define the way add the columns. It's a flexible schema. Data compression. It's a very important part. It's based on the Google's compression algorithm. Reduced data drastically. And it's very efficient algorithm they have for data compression in Cassandra. Data consistency, that is, we discussed about eventually consistency. We can make a partition tolerance in terms of trade-off between to define that availability and consistency. So we can tune it the way we want. We want it to be consistent, yes, but it will cost the availability of the database. We can that is, we can configure how we wanted to configure our Cassandra database. The another thing is advantage is no need for caching software. That is highly cached. Like you can store onto the multiple nodes. So every memory or data is cached onto that particular server or particular node. And from there, and they have a proper this caching algorithm, so where it eliminates like memcache or other kind of caching algorithm when we are dealing with Cassandra. No single point of failure. That is um, because all nodes are same and they are replicated for data redundancy. So you can read and write from any node. So any failure in any particular node will not affect. So as you see the 5-ring cluster which we had previously, if any node goes wrong, we are definitely not still able to get our data. Cassandra provide a like a which is you can replicate the data, distribute it very transparently. It is handled very efficiently by Cassandra. It is multi-data center capable, like you can replicate among multiple data centers. You can also take the benefit of cloud computing, and you can also make the hybrid cloud. So whatever way you want to replicate the data, it can handle. The other thing is the SQL language I discussed earlier. It's an efficient language, and it's provides the similar kind of structure. The other thing is the data administration, data migration, and development, and these is like other core hand services which is provided with the Cassandra. So these are some of the Cassandra advantage we have. So after that, now that the question is like we have this whole Cassandra. So that I think if I just wanted to quickly check if someone have uh, any question. So let's move to the who uses Cassandra. So the Cassandra is used by the Netflix. Uh, it is used by Twitter. It is used by Facebook for social graph. It is used by HP, Cisco, USB Bank of Switzerland. It used in highly means like it's a DataStax is a commercial supporter of Cassandra, and as at COSO IT we use the Cassandra in our all applications. So these are the some of the companies which is using different way these database. Now we go into the demo and I will show you the little bit of Cassandra demo. In this we have Cassandra installation directory structure with configuration file, startup Cassandra, node tool, we will discuss about NoSQL and CQLS LSH. We will create key space tables, we insert the data, we how to display the data and update or delete the table data with this demo. So let's jump to demo. For that I need to switch the system. So just give me a sec. I will do that. Uh, Okay, so if you can see my screen, right? So here you can see I just opened a terminal, and first let me exit from here. We can display some of the thing. So it has a little degraded performance. If you will see that we have a Cassandra installed, and this is, we are working with a Cassandra tarball, and this is Apache Cassandra 309, and this is the latest release. And I will show you you can download this Cassandra software from directly from Apache download any mirror site. And we are working with this Cassandra uh, uh, 309. And first thing is I wanted to show you in the configuration. uh, just bear with me, it will not take. So the one of the most important file in the Cassandra is cassandra.yaml. um, and if you will go into the configuration, you will see cassandra.yaml file, which is so always when you are working, make a copy of cassandra.yaml.old. It is always good so that you can recover. If I uh, so I can show you few things in this Cassandra YAML file. One thing is the cluster name. That is the important parameter. Another is the number of tokens. So it tokens defined like when you're talking to a node, and it is generated number of token to communicate and store the data. There are the other parameter which is important is the seed. So that defined your master node, which is where we provided the seed as a BD1, big data 1. Another thing is the RPC protocol. The RPC communicate on the port 9042, and if we see that I think I will be this is after this file. If you are looking at first time, it might be overwhelming, a lot of information, but RPC address we defined at 0.0.0.0. So like we can, any application can communicate with Cassandra on RPC address. um, uh, uh, so RPC port is 9160. And the other thing which I wanted to say that is we have the snitch. So we have to see so we have to see the snitch what we are using. There are multiple snitch. So endpoint snitch, we will see there generally there is a simple snitch, or we are rack inferring snitch based on the requirement. So this is the way you can tune it. You can provide your YAML file. This is with we did it for. So generally to start your before I think move, I will just quickly move to. So that is the cassandra.yaml file, which when you are configuring your Cassandra. And if you will go to, I will say that if you will go to bin directory, and there you will find very important commands. And one of the command which we wanted to CQLSH, that is one of we will be using it. And another thing is the node tool. It's a very powerful, very important command, very utility. And the only thing is, like, you will be using node tool all the time. So that node tool, and can use the status, node tool status. So it so if I can show you that the interpretation, what it does is, it shows un is as the first column. So it is up and normal, so that it says that our node is up and normal, it running. It has the data size, it can tell, because we just created it does not have much data. It shows how many token, and it shows in distribution how much it owns effectively. And it gives a little bit of rack parameters. So we just saw the node tool command. Now we will move to a CQLS as such, where we will see how we can create the SQL like structure. I will so we can have, so if you see that you will get a like SQL prompt, you will get a CQLSH prompt, and that is, so that say the native protocol. You can see that what we just discussed in, and when we were discussing design methodologies, and it gives the Cassandra version, CQLSH version, and SQL query language version. Clear? So what we can do, so there is a describe command, um, and key spaces. You can see this describe command tells what key spaces you have. So this is the system which comes by default: system, traces, schema, auth, system, and distributed. You can look into the any key space just using describe key space and then key space name command. But what we are going to do, we are creating a key space. So create uh, key space, and for example we create a key space called security. And so now when we are creating this key space, I think like that is mostly that is your lowercase is what we used in Cassandra, and it can have a lot of way of doing it. So replication strategy, we can survive the simple strategy for now. So we can define simplest strategy, and replication factor is 1, and then we will just creating it this key space. So if you will see this describe command, so you see that whatever the key space you have created, now we can just go and use this key space, use security. So now we are into the security key space. That is what we called the database, similar to the relational database. So the other thing is similar to I will create a table users. So we can say that user ID worker, we say primary key, and we can go again. We can say first name. Again we can define as a varchar, and we can go the last name. We can again define it varchar, and we can define the age int, and we can define the sex as a, and we can just hit enter. And the way we can just do that describe is like again to describe table users, and you can see this the table definition which has been created. So you have this table here in Cassandra. The thing which we can do is we can insert uh, into users table. So user ID comma first name, last name, and we can have age, and then we can have a value, for example ck010. First name is we can say Tom, say 58, and sex is male. So this is a similar concept. We just inserted a data. If you want, we can just go and insert other data. So we can have 10, 11. We have Alan, sample. We can have 27 and male. So we have created this data, and we can create one more. We can, for example, we create a key 12, and we can say Kate, and we don't Nicholson, and is we can have 23 with female. Now as we created these rows, we can use this query language to just give the data which is coming from user ID and age, first name, last name, sex, and so you can see that like we have these data inserted, and that is similar to, it can be put as in a column and value. But if you will see that the data, how the data is stored is user ID with the values, column name and value, column name and value, so that this structure is flexible. Now the other thing which I wanted to do is I wanted to update a for example we have to update the age. uh, is for, we wanted to, for example, we wanted to set is for Kate, where user ID is ck012, and we just wanted to update user's age. And if you will see like this 23 should we can use the up arrow to just get the same result, and now this row is updated to 25. So you can see this third row is updated to 25. Another thing is we wanted to remove a data, so which we can use the delete command, delete users, where uh, we can have a user ID again, delete from users, where user ID is equal to ck 010. So that way we can also remove the rows. um, Let me just go to another screen. I think we have this screen, and I think this screen, so it's a little what we did is we just ran, like if I can show you, this is a little bit. So we ran this Cassandra, we saw that Cassandra status, and we run in a foreground mode. So whatever the log is happening, it is coming it here. So I think there is nothing to read it, but it gives like things are running, and our cluster is in a good health. So this I can go back. Okay, so I just for now I think like we have covered a lot of ground, and we are almost an hour for now. I just wanted to just see, we can just switch back to our schema, and just wanted to know if you have any questions, and if you wanted to know a little bit more. So I'm switching back to the our slides. So I just wanted to go back again. We in the demo we saw the Cassandra installation directory structure. Not all, but I think important directory bin and conf directory we discussed. Overview of configuration file, we gave like some of the places which we have to look for. Startup Cassandra, I think this has been this is we just already started the Cassandra to avoid the time delay. We just discussed about the node tool and CQLSH, these command line tools. We created a key space, then we created a table, we insert data into table, we display that table data what was inserted, and we try to update and delete table data. So this conclude for our presentation for today. I just wanted to if you have any questions, you can just, I guess, shoot to us. uh, Once again, thanks for your time, and it is wonderful to have you all and discuss about some of these technologies. We have our announcement. We are going to have a next meetup on Apache Solar on 12th November, and we are going to be in the same time, 7:30 a.m. EST. You can just reach us. That is, we have COSO IT as our primary sponsor for this meetup, and this the COSO IT is a company who works in the big data, and they are provide the different kind of consulting and training solutions. So like if you are looking for some of the further things, you can just look at www.cosoit.com or reach us at connect@cosoit.com. So once again, thank you for your time, and if I wanted to see if any one of you have any question, just raise your hand, or like uh, uh, then I, otherwise we'll see you next time during on 12th November. So let me know. I will wait for a minute for any question, and then we will finalize our let me know if you have any question. Okay, so great. I think like we are good for now. And once again, guys, thank you a lot, and have a great weekend ahead. And whoever is in India, I heard like there's a festival season. So happy holidays, happy Diwali, and happy festivals. And it was again a pleasure. And thank you for your participation. Um, have a great weekend ahead. Thank you.